A strange light had begun to rise from the shoulder of Orion, and astronomers quickly realized that something inside Betelgeuse had shifted in a way no one expected. The star suddenly grew brighter with an intensity that broke its usual pattern, and this silent change turned a familiar point in the sky into a new mystery waiting to be uncovered. Its glow increased by half, pushing it higher on the list of the brightest stars visible from Earth, and this surge created a wave of questions about what could force a giant so old to behave so differently. Researchers watched the change with growing curiosity because the timing felt unusual and the scale of the brightening suggested that something deeper was unfolding beneath its surface. Each new observation added more tension to the story, and the question became harder to ignore as the star continued to shine with its strange new strength. What if this unexpected glow is the first clue to a far bigger event waiting in the dark? Betelgeuse stands as one of the largest stars ever observed, and its massive scale makes every change in its behavior feel more dramatic than anything we see in normal stars. If it replaced our Sun, its outer layers would reach the orbit of Jupiter, which shows how enormous this red supergiant truly is. Scientists have followed its life for decades because they know it will eventually collapse and create a supernova, a burst so powerful that it will shine 100,000 times brighter than usual. This explosion would be visible during the day and strong enough to cast shadows on the ground at night, which explains why astronomers watch every shift in its light so closely. Earth sits 650 light-years away, far enough to be safe but close enough for us to witness the display when the moment finally arrives. And this distance turns Betelgeuse into a natural laboratory for studying how giant stars age. The combination of its size, brightness, and unstable state creates a sense of suspense because each new observation feels like it might hold the next important clue. As the mystery grows, one question rises above the rest. Could the recent changes be the first signs of something deeper waiting to reveal itself? The first signs of trouble appeared at the end of 2019 when Betelgeuse began to fade in a way that felt completely unnatural. People who looked at Orion during the winter months noticed something different because the star that normally burned with a steady brightness now seemed weaker, and the change was clear even without a telescope. Astronomers quickly confirmed that the decline in light was real, and their measurements showed a dramatic drop that did not match any familiar pattern. The speed of the dimming surprised researchers because large stars do not normally shift that quickly, and this raised early questions about what might be happening inside such a massive object. Observations from the Very Large Telescope revealed an expanding photosphere that offered the first major clue to the mystery. Throughout most of 2019, the outer region of the star moved outward at 8 kilometers per second, a rate that suggested the entire surface was swelling as if something deep inside was pushing against it. This expansion changed the shape of the visible surface, and astronomers studied the images closely because the star looked more distorted than usual. The unusual movement drew attention from research groups around the world who wanted to understand why a red supergiant would suddenly behave in such an unstable way. By November 2019, the outward flow of material came to an unexpected stop, and the sudden shift marked the beginning of a new phase in the mystery. Astronomers captured fresh images that revealed two disturbing features which made the situation even harder to explain. The first feature was a large dark region that appeared across the southern hemisphere of the star, and this patch contrasted sharply with earlier images taken at the start of the year. The scale of the dark area showed that part of the photosphere had changed more dramatically than anyone predicted, and the difference in brightness created a lopsided appearance that worried researchers. The second feature was a drop in temperature across the same region, measured at 80 Kelvin, which indicated that the surface had cooled more than expected. A cooling event of that size suggested a major disturbance in the outer layers, and this added more pressure to the theory that something powerful had been rising inside the star before breaking through the surface. Between late January and mid-February of 2020, the brightness of Betelgeuse reached its lowest point ever recorded, and the dimming became strong enough for millions of spectators to see without any equipment. The sight caused emotional reactions among the public because many people feared that the star was preparing to explode, and the long history of its unpredictable behavior made the situation feel even more dramatic. As the months passed, the brightness slowly returned, giving astronomers a chance to examine the changes more carefully. The recovery showed that the dimming was not a simple event, and scientists realized that multiple factors had combined to create one of the most extreme episodes ever seen in a star of this size. Each piece of data added another layer to the puzzle, and the unusual timeline forced experts to consider new possibilities about the forces inside dying giants. This left the scientific community with one lingering question that demanded an answer. What kind of event could drain so much light from a star so quickly? The idea of a massive eruption began to take shape when astronomers compared the dimming timeline with the images captured before the star reached its weakest state. They noticed that the surface looked disturbed in a way that suggested something powerful had forced its way upward, and this observation pushed researchers to explore a far more dramatic explanation for the fading light. A growing number of scientists believed that Betelgeuse had released an enormous burst of material from its outer layers, and this event pointed toward a rare process known as a surface mass ejection. Unlike smaller eruptions on ordinary stars, this kind of outburst involves huge amounts of energy, and the scale of the disturbance indicated that the star had experienced something far beyond normal behavior. Measurements taken from the Hubble telescope provided strong evidence that a wave of hot gas had risen from deep inside the star before breaking through its visible layers. This rush of material traveled outward with incredible force, and the sudden release disturbed the delicate balance that usually controls the surface. The eruption was so intense that it pushed a massive cloud of stellar material into space, and the density of that cloud was far greater than anything previously observed on a star of this kind. The amount of mass expelled during this single event was measured at 400 billion times more than the material typically released during similar outbursts on other stars. Researchers estimated that the cloud contained several times the mass of the Moon, and such an extreme amount revealed how violent the eruption must have been. A burst of that size would naturally disrupt the appearance of the photosphere, and the dust forming within the cloud would block a significant portion of the star's light. As the cloud cooled while drifting away, it began to create molecules and dust particles that made the star appear dimmer from Earth. This cloud acted like a giant shield, reducing the amount of light reaching us and making the dimming episode even more dramatic. The idea of a star ejecting that much mass shocked scientists because events of this scale had never been directly observed before. Most stars lose mass slowly through winds moving outward over long periods, but Betelgeuse seemed to have lost a huge section of its outer layers in a single violent moment. The eruption left Betelgeuse temporarily off balance, and this instability helped explain why its brightness changed so unpredictably afterward. The star behaved as if it were recovering from a major injury, and its unusual appearance supported the idea that it had expelled part of itself far too quickly. The most surprising part of the event was how quickly everything happened, and the speed of the eruption challenged many models used to study dying giants. This forced researchers to change their view of what a red supergiant can do when it reaches the end of its life cycle. Astronomers continued to observe Betelgeuse with every instrument available, hoping to track how the star recovered from such an extreme event. They wanted to understand how long the disturbance would affect the star's outer layers and whether another eruption could occur in the future. As they collected new data, the mystery surrounding the eruption grew deeper, and each clue raised new questions about the forces at work inside the star. This led to a single thought that captured everyone's attention. Could the eruption be the warning sign of even greater changes waiting inside the core? The most unsettling change appeared when astronomers realized that Betelgeuse had suddenly altered the rhythm of its natural pulse. For many years, the star followed a steady cycle of brightening and fading every 400 days, and this pattern helped scientists understand its internal structure. This long cycle was treated as a guide for predicting how the star released energy, and the stability of that rhythm made it one of the most reliable features of Betelgeuse. Observers used it to track the rise and fall of temperature within the outer layers, and any small variation in timing usually matched the models built to explain its behavior. Everything changed after the eruption because the 400-day cycle suddenly collapsed, and the star began pulsing in only 200 days. The shift was so abrupt that astronomers first questioned their data before accepting that the star had genuinely changed its natural rhythm. A pulse describes how the star expands and contracts as energy moves through its layers, and the new period meant that something inside the star had disrupted the normal flow. The sudden contraction of the deeper regions combined with the expansion of its outer layers, and this tension explained why the cycle shortened so dramatically. Computer simulations helped reveal a deeper story behind the shift, and the models pointed to an enormous bubble of hot gas rising from the star's interior. This bubble broke through the surface with enough force to disrupt the entire pulsation system, and the pressure from the eruption changed the timing of the internal waves. The movement of the bubble could be compared to a large object rising through boiling liquid, and the star's outer layers reacted by swelling outward while the deeper material tightened. The collision of these motions created a new heartbeat for the star, and the weaker gravity in the swollen regions allowed the 200-day cycle to take over. Astronomers believed that the star would eventually return to its original rhythm, but the process could take between 5 and 10 years because the internal layers needed time to settle. The slow path to recovery showed how deeply the eruption had affected the structure of the star, and the unusual rhythm matched the signs of a system struggling to regain balance. The new cycle drew the attention of research groups worldwide, and many found the rapid shift difficult to explain without considering the extent of the eruption. The fact that a single event could disrupt a long-standing pattern made scientists rethink what they knew about the stability of red supergiants. Each new measurement highlighted the sensitivity of the star's internal layers, and the complexity of the pulse revealed how much energy was moving through the system. The 200-day rhythm showed that the forces inside Betelgeuse were in a state of tension, and this tension raised questions about what deeper changes were taking place. The change also offered a rare chance to study how massive stars respond to violent events, and this opportunity encouraged teams to track every fluctuation. The data showed that the star was moving through a unique phase, and this phase allowed astronomers to watch the internal structure shift in real time. As the star continued its recovery, the unusual rhythm remained a reminder of how unpredictable dying giants can be, and every pulse carried a hint of the forces hidden beneath the surface. That uncertainty led astronomers to a new question that guided their next steps. Could the broken rhythm be a sign that the internal layers are preparing for an even greater event? The possibility of a supernova has surrounded Betelgeuse for generations because every major change in the star's behavior fuels the idea that it could be approaching its final moment. Astronomers have long studied the way massive stars die, and the unusual activity around Betelgeuse during the past few years made people wonder if the countdown had already begun. A supernova marks the collapse of a star's core, and the explosion releases enough energy to outshine an entire galaxy for a short time. For Betelgeuse, this event would make it shine 100,000 times brighter than usual, and the blast would be visible even during the day from Earth. Scientists estimate that Betelgeuse sits about 650 light-years away, which is far enough to protect us from the harmful radiation. The distance also means we would have a perfect view of the explosion when it happens, because the light would travel directly toward our sky. Even with the dramatic dimming and the violent eruption, astronomers believe the star is still in an earlier stage of its life cycle than people imagine. The current evidence points to Betelgeuse being in the helium to carbon fusion stage, which is not yet close to the final collapse into iron. Massive stars must move through several fusion stages before reaching the point where the core can no longer support its own weight, and Betelgeuse appears to be progressing through these stages slowly. This timeline suggests that the explosion could occur anytime within the next 10,000 to 100,000 years, which means the event is not expected in the near future. A surprising detail about observing distant stars is that everything we see is already hundreds of years old, and Betelgeuse is no exception. Because the star sits 650 light-years away, the light we observe tonight actually left the star centuries ago, which means any supernova happening right now would not reach us until long after our lifetime. This idea creates a strange sense of distance because we are watching a version of the star that no longer exists, and the true state of Betelgeuse remains hidden behind the limits of the speed of light. The gap between what we see and what is real adds mystery to every change the star displays. Despite this delay, astronomers can still identify signs of instability in the structure, and the recent changes show that Betelgeuse is entering a more unpredictable phase. The violent eruption, the shifting pulse, and the uneven brightness all point to a star that is moving deeper into the final chapters of its life. Even though the supernova may not be close, the star's growing instability provides valuable opportunities to study how massive stars age. Each new observation captures a moment in the story of a giant slowly losing its balance, and these moments help researchers refine their understanding of stellar evolution. The next major question focuses on whether the recent events represent a pattern or a temporary phase, and this question drives many of the current studies. Astronomers want to know if the disturbances suggest that the internal layers are changing more rapidly than expected. Betelgeuse continues to behave in ways that challenge familiar models, and its unpredictable nature forces scientists to consider new theories. The possibility of hidden processes deep within the core adds tension to the investigation, especially when the surface shows signs of repeated instability. As researchers track the changes over time, the mystery of Betelgeuse's future grows even deeper, and each new discovery adds another waiting clue. This leads to a final question that sets the stage for the next part of the story. Could the next unusual signal reveal something about the structure hidden beneath the surface? Betelgeuse has shaped human imagination for thousands of years, and its shifting behavior continues to influence the way different cultures understand the night sky. Long before astronomers measured its temperature or tracked its pulse, ancient civilizations studied its glow and used it to build stories that reflected their fears, beliefs, and hopes. The earliest known meaning of Betelgeuse comes from Arabic traditions, where its name was linked to the body of a great mythical figure. Some translations described it as the armpit of a giant, while others interpreted it as a shoulder or hand, and this range of meanings showed how important the star was in ancient storytelling. Different cultures shaped the star into symbols that matched their own worlds, and each region formed a unique connection with its bright red light. In Japan, the star represented a severed limb, which added a dramatic tone to their legends and emphasized the dangers of the celestial world surrounding them. Communities in Brazil viewed Betelgeuse through a completely different lens because they connected it to the leg of a turtle or the hind leg of a caiman. These symbols reflected the wildlife that shaped their environment, and the star became a reminder of the creatures that guided their traditions. In Hindu mythology, the star was known as the Moist One and belonged to a lunar house associated with the powerful storm god Rudra. This connection linked Betelgeuse to themes of destruction and renewal, and the star played a role in predicting changes in the natural world. Northern communities such as those on North Baffin Island and the Melville Peninsula used the rising of Betelgeuse as a signal for the return of spring. The appearance of the star helped them measure time during long periods of icy darkness, and this relationship showed how closely people depended on the sky for survival. In Macedonia, the star symbolized the importance of domesticated animals because it appeared during the seasons when agricultural work intensified. It became a cultural marker that tied the cycles of farming to the rhythm of the sky, and this connection endured for generations. Artists, writers, and filmmakers have also shaped Betelgeuse into a symbol that carries emotional depth because its brightness makes it one of the most recognizable stars in the world. The way its light rises and falls feels dramatic and mysterious, and this pattern feeds into the stories people create about the end of great cosmic events. Even today, Betelgeuse inspires new interpretations because its recent behavior has captured the attention of people who normally do not follow astronomy. The idea that a familiar star could change so suddenly makes the universe feel alive, and the cultural meaning of Betelgeuse continues to grow with every new discovery. These stories show that Betelgeuse is more than an object in space because it serves as a bridge between science and imagination. Its unpredictable nature invites people to explore their own questions about the universe, and the star's history reflects the way humanity searches for meaning in the unknown. As Betelgeuse moves through its unstable phase, the cultural weight behind its light becomes even more powerful. People wonder whether a future explosion would reshape the stories told about the sky, and the possible supernova raises questions about how this ancient symbol might transform. The next chapter of Betelgeuse's story may arrive without warning, and every change in its light could shape the way future generations interpret the universe. This leads to the final question that guides the rest of the investigation. What story will Betelgeuse tell when the next great change appears? Betelgeuse has revealed more secrets in the past few years than many stars share in a lifetime, and every change in its light reminds us how fragile and powerful the universe can be. The dimming, the eruption, the shifting pulse, and the cultural weight behind its glow all come together to form a story that stretches across science, history, and imagination. Astronomers continue to follow every signal from the star because each new observation offers another clue to its future, and the search for answers becomes more important as Betelgeuse moves through its unstable phase. The mysteries hidden in its layers challenge familiar ideas about how giant stars grow old, and this challenge pushes researchers to explore possibilities they once ignored. Even though a supernova may not arrive soon, the star's unpredictable behavior shows that great changes can appear without warning, and this truth keeps the scientific community alert. Betelgeuse reminds us that the universe is always shifting, and the story of this red giant is still far from complete. As the star continues to change, one question waits for all of us. What do you think Betelgeuse is preparing to reveal when the next burst of light reaches our sky?